let me try. So this is a widget which I developed, and this widget imports data from the same Owens Valley Solar Array in a form appropriate to make image. The physical principle in making images is observation of the sun of the source with a number of antennas which form an array. And what antenna measure? They measure phase difference in signal arriving between different antennas. And from this difference of arriving phases, you can compute direction on the sky where from the photon came. And this is a principle which is in the foundation of interferometry and in the way how images are produced. So let me show something. Oops. First, what you can do data selection. So here you have the same dynamic spectrum, and you have ability to select a single time or period of time. This area shows you start time and this end time, and here you have boundaries of this. And you also can select range of frequency, which is already done here. It's all frequencies which observed with OFS are listed here. And here we selected a subset of this frequency around the spectral peak here. And two dotted lines, horizontal dotted lines, demarcate the frequency range used for synthesis. Then, what you are doing, you have so-called dirty image. And dirty image shows you interferometry picture between sum of interferometry picture related to all antenna pairs, to all frequencies and all time scales. And the brightest point here on the dirty map, somewhere here, shows you the right location of your source. Now, these are a number of antennas which are used to create this image. For now, antenna 7 was discarded, and if I add antenna 7, you have entirely different picture. This happens because for this and for many other observations, not for all, antenna 7 has some malfunction. So before producing image, you have carefully check all antennas and see how this works. So right now, if I deselect antenna 6, it just changed a little bit, but the location of the source stays there, right here. So when all selections are done, we go to image production, and we have a couple of options. We can have so-called clean map. So this was a dirty map with a lot of secondary maxima, and the goal of image production is to clean up the dirty map and produce so-called clean map. To do so, within this widget, I can just select option compute all maps in range, and here something already pre-selected, and here still there are some artifacts around the main source. And to make a better job, I can select a little bit better imaging algorithms which use clean and self-calibration, which uses some equations and dependencies which must be fulfilled between different antenna pairs. If I do that, I hope it will produce a little bit better image. Yeah, but it takes a little bit more time. So we can go here, and we can go and enhance this image. We can import images from other instruments. In this case, it's X-ray image, and we can right now I imported X-ray image, and white contours are radio image plotted on top of this X-ray image. So you see that two different instruments which produce data in X-ray range and in radio are basically very much connected and similar to each other. They come from the same area as the sun. And this is the information which Jello mentioned we are using to eventually create 3D reality of the flame. But what else can be done, just for fun? We can deselect, for example, this frequency synthesis, and in this case, you can produce maps at each particular frequency, and by the same way. You see that at different frequency you have a little bit different images. You compute them one by one, and a couple more still remains to be done. Yeah, and after that, what else can be done? You can go to this image post-production, and you can create a movie and save it as place selected frames. And this, I think this.
Did you save it?
I will. I think it must be saved. Let me check. GX modeling. It's default MPG. So when you play, you save it in your working directory with default name, and you can now play it with Windows Media Player, for example. So you see what happened. I selected like very few time frames per second, and if I want to see it more clearly, I can go here. So how many?
You can put 1 frame per second if you want.
1 frame per second, yes, and do that. So you have to wait like 7 seconds until you create it, and wait a little bit more while it saves the movie.
Yeah, a slow movie takes more time to create because it actually creates intermediate frames to fill the time.
Yeah, it's bigger now, but you will see evolution with frequency more clearly, in more detail. So same way we can produce movie versus time rather than versus frequency. If I if I would deselect the other check mark. And so this is like a couple of simple examples of power of data and tools to work with the data to produce physical results we are looking for. So okay, I am done with my part of the presentation, and if you have questions, please ask, and as Jill said, we will provide you with some data file and some instructions how to play with. Questions?